So, hello everyone, this time in English, and I'm gonna talk about the current and future upgrades for the M1 Abrams main battle tank. So, the upgrade program that is recently done by the US Army is Engineering Change Proposal 1. Initially, it was a single program. However, in time, it became obvious that not all required technologies will be available in the same time to perform the upgrade, and not to delay the program. The US Army decided to split the Engineering Change Proposal program into two separate sub-programs. So we have the ECP1A, which is mainly focused on resetting space weight and power cooling limits of the tank. So they are being reset, so the vehicle can accept more upgrades now and in the future. And the ECP1A become the M1A2 SEP version 3. Now, what is the part of the ECP1A program? First is the network capability. So we have the new HMS radio system and a new JBCP mission command or battle management system that is replacing the current FBCB2 system. Power generation and distribution. So we have a new battery monitoring system, increased amperage alternator, and a new slip ring that can provide more data transfer between the turret and hull computers. Now, about the computers. In the past, the M1 had line replaceable units, boxes with all the electronics. The SEPv3 have line replaceable modules, which means that you do not need to replace the entire unit, the box, but you just simply open the box and replace your electronic cards there. Just like in your home PC. You want to replace the graphic card? No problem. Now, what are the electronics with line replaceable modules? It's a mission control unit, turret control unit, hull control unit. You have the commander's display unit, driver's control panel, gunner's control panel, and all of them will have a new common high resolution displays. Sustainment. The vehicle will receive the new auxiliary power unit. In the past, all Abrams variants had APU in one form or the another. The first APU, fitted in the 1980s, was a box mounted to the rear left sponson of the hull. However, this APU, it was working okay, but the mounting system was not perfect, and the APU could be lost in difficult terrain. The second APU variant was the one mounted in the turret rear transport basket. It was okay, but the problem was that it was not armored, and the placement could cause some engine fires if the APU was shot with the armor-piercing rounds and the fuel inside the APU started to burn and leak onto the engine deck. It happened sporadically, but it happened. It was not a perfect solution. And it's mainly seen on the M1A1s of various subvariants, and also on the basic M1A2. Now, the M1A2 Sep version 1 and version 2. The version 1 had the APU in the rear left sponson. Inside it, it was under armor auxiliary power unit. However, the problem was that this APU didn't have enough power when the time progressed and the tank received more and more upgrades. The APU didn't have enough power to provide enough power. So what was the solution? Well, most M1A2 Sep version 2s had this APU replaced by the so-called Hawker batteries. So it was additional battery pack. Again, it was not perfect. So the US Army still wanted the true APU. And here we come with the M1A2 Sep version 3. Finally, the technology progressed enough that we can have a compact APU that fit into that space provided for it in the Sponson box, and also generates enough power to power up all the new systems the tank have. Okay, lethality. Lethality is improved primarily by the new ammunition data link and FCS fire control system upgrades. This means that the tank can finally fire programmable munitions. These programmable munitions are M1A2SEPv3 high explosive multipurpose, developed within the Advanced Multipurpose program. It will replace the M830 HEAT, M830A1 MPAT, M908 HEOR, and also M28 canister round. The M1147 HEMP have three fuse modes. So we have a standard point detonation on impact. We have delay armor piercing, and the prototypes of this ammunition, previously it was designated as XM1079, but later the designation was changed to XM1147, and the series produced round will be the M1147. So during the tests, prototypes were capable to pierce through turret side armor of the T-55 tank. This is around 150 millimeters of cast armor. So pretty impressive for an HE round. And then there is the final operating mode, which is the airburst. So with that kind of ammunition, the crew can hit, for example, ATGM crew or infantry squad hiding behind cover, like a sunburn. Okay, the second type of the programmable munitions is the M1A2 APF-SDS. The question is why the APF-SDS is programmable. We don't know that yet. There are several options that do not exclude each other mutually. For example, the ammunition, including also the M1147HE, that the ammunition, when it's loaded, it can automatically set FCS for the specific ammunition that is loaded. So the gunner do not need to do it, and we have the human error out of the box here. The tank will automatically itself know what kind of ammunition is loaded. Another reason why the ammunition data link is useful is because perhaps the ammunition can inform the FCS and the crew, for example, what is the temperature of the propellant charges. Another reason, of course, programmable fuses. In case of the M1147HE round, well, it's obvious, but the APF-SDS round, can it be programmable? Perhaps yes. Perhaps the round have a sort of detachable precursor that before the penetrator hits the target, the precursor detaches, and because it's lighter, it can move a bit faster than the main penetrator, and that precursor can initiate explosive reactive armor or active protection system, or both, thus creating a clear path for the main penetrator. Okay, protection. On this slide, we do not see one protection measure that was added, but the primary protection improvement is the new armor package. And funny thing, this new armor package was added in the previous versions as well, but I will talk more about this later. Another protection measure is the new electronic warfare system Crew Duke version 3. This is mainly a system of jammers against radio-controlled IEDs, but we can assume that perhaps it has secondary applications, for example, jamming communications and perhaps something else. Logistics. The vehicle health management system. Well, the M1A2 Sep series had such systems in the past, but this is a new system, obviously improved. And as far as we can tell from various DOT&E reports, it seems that the M1A2 Sep version 3, despite heavier weight, which I will talk later about, is more reliable than the previous lighter variants. Okay, this was the ECP1A or M1A2 SEPv3 upgrades. But there is also ECP1B, or the future M1A2 Sep version 4. So again, what is improved in the M1A2 SEPv4? Protection. Laser warning receivers are added. Directional smoke grenade launchers, probably a Rheinmetall ROSI system. Updated crew fire suppress system, the AFES, or Advanced Fire Extinguishing System, which is installed in various variants in all US Army armored fighting vehicles. Environmental control system, so probably new air conditioning system, and perhaps also new nuclear, biological and chemical protection system. And also vehicle generated smoke. It seems that the smoke generator in the engine will be upgraded or replaced with a new system. The previous variants, all of them, including the M1A2 SEPv2, also have this system, the smoke generator in the engine. However, the system is not used if the JP8 fuel is used. Only diesel fuel can be used with the smoke generator. Another upgrades. Improved Commander's Independent Thermal Viewer, CITV. So the CITV will be upgraded with the new third generation IFLIR, improved forward-looking infrared. It will also receive laser rangefinder, laser pointer and color camera. Why the laser pointer? Well, the tank can further use its far target location system, and I will explain how it works. So the far target location system consists of the north finding module, sensor that detects where the hull is facing. It is facing northwest, east, etc., etc. The turret facing sensor, so how the turret is facing relative to the hull, which direction. And then there is also the fire control system and the battle management system. So for example, the crew sees and identifies target at 8,000 meters from their position. So obviously the target is beyond the range of their main gun, or effective range of the main gun. And fire control system will not allow them to fire accurately at that target. Okay, so for example, the gunner or the commander can lace the target, so they have the distance for the target. Now the computer calculates what are the coordinates, GPS coordinates of the target relative to their own tank position, the north, and how the tank faces the target, the hull and the turret. When they have the coordinates, through the FBCB2 or the JBCP system, these coordinates can be sent to higher echelon command, other vehicles that have the same system, for example, other tanks. So one crew can inform without using the radio that, hey, here there is a target, there is a danger, threat. Or send it to higher echelon, or they can directly send these coordinates for the artillery support or air support. And if the artillery decides to use guided munitions, the commander with the improved commander independent thermal viewer can use the laser pointer to lace the target for the artillery munitions or the aircraft munitions that are laser guided. Okay, and then there is a color camera. So Commander now will also have the capability to identify targets better. Sometimes in the thermal sights you can't do that properly. With color camera it's much easier, and we can see the color. For example, there is a counter-insurgency operation, so the crew can identify, for example, a car that is have specific color, etc. Okay, and also the gunner receives the new improved gunner's primary sight. Again, third generation FLIR, improved laser rangefinder. I wonder what are their improvements. It's obviously eye-safe. Already used laser rangefinder is eye-safe, but perhaps there are other improvements. Perhaps to guided munitions fired from the main gun. Who knows? But this can be excluded. And the primary day channel optics are replaced by the new color camera. Of course, these color cameras will be the HD. One would ask, why the color camera and not the optical channel? Because cameras are more compact and they are lighter. They are simpler in many ways. And the view can be from the camera, what the camera sees can be, the image can be sent via cable to the gunner, TC, maybe other crew members. Okay, advanced multipurpose round. Well, it will be integrated in the M1A2 SEPv4. The new meteorological sensor for improved firing accuracy, and also the new enabling enhancements like improved onboard diagnostics, onboard video capturing, very useful for training but also for the missions. Continued architecture standardization via Victory architecture compliance. All US Army armored fighting vehicles receive the Victory architecture for the electronics, and integrated Miles LTEC. Okay, let's talk about the armor upgrade. Here we have a prototype vehicle 4. And as we can see, it have welded to the turret front, hull front and turret roof weight simulator plates. Each plate is around 50 mm thick, maybe more. As we can see, each turret face have 4 plates welded. The hull front have 3, maybe 4 plates welded. Okay, one will ask, what does that mean? Well, these plates simulate the weight increase of the armor because the prototype is built on the M1A2 SEPv3. So that tank, still in its integral armor cavities in the turret and the hull, have the old armor package used in the M1A2 SEPv2. So the weight of the old armor package plus the weight of the weight simulator plates, it equals weight of the new armor package. The weights on the turret roof might mean something else, either improvements in turret side armor, perhaps some electronics upgrades. However, we need to remember one thing: newer electronics become lighter, so perhaps these are general weights to increase the weight, simulating, for example, the vehicle combat weight, plus the new armor package. Here's another photo of that prototype, and we can see very good the front turret weight simulators, the turret roof weight simulators, and also the whole front weight simulator plates. Interestingly, as you can see in the back of the turret, there is a cylindrical antenna. This antenna is the part of the Crew Duke version 3 system. There is a second antenna next to the driver hatch on the front fender, or mudguard if you wish. You can see that on that photo and on the other ones. Here is again the photo of the M1A2SEPv3 prototype with the new armor package weight simulators. And the Duke version 3 antennas are seen here very well. So we can assume that there is a general jammer in that cylindrical antenna, and there is also a directional jammer in the front of the vehicle. And here may be one explanation. As we know, in the media for some time, the designation codes M1A2C and M1A2D are present. M1A2C obviously becoming the M1A2SEPv3 and M1A2D, M1A2SEPv4. However, one thing, M1A2C and M1A2D were proposals from the US Congress or Senate Defense Committee. It was never, it seems, accepted by the US Army, and the US Army still calls these tanks M1A2 Sep v3 v4. So the Sep is still the official designation. I have a theory that perhaps it was done because the M1A2C and M1A2D are two similar designations to the M1A2 Sep v2 export variants, like the M1A2S for Saudi Arabia, M1A2K for Kuwait, and M1A2T for Taiwan. However, M1A2T might be also export variant of the M1A2 Sep v3. Who knows? We will see in future. Okay, and here another thing I tried to classify because I found peculiar thing. On the upper part of the photograph, we have the M1A2 Sep v2 in the tan camouflage. Bottom is the M1A2 Sep v3 in the olive camouflage. Now notice on the tan tank the side turret series number 4475M. On the Sep v3 turret series number is not very well visible, but we can see the letter M on the end. What does that mean? As we know, the series numbers on the side of a turret, if they are ending with the letter, means the armor package that is used. Okay, so as we know, in the past, starting with the M1A1HA heavy armor, the tanks have the serial numbers ending with the letter U, meaning that these tanks had the heavy armor package with the depleted uranium alloy components, most likely plates. But from something around 2015, maybe 2012, we could see some new M1A1SA tanks and the M1A2 Sep v1 v2 tanks with the same series number ending with the M letter. And the new M1A2 Sep v3 ends with the M letter as well. What does that mean? Well, I have a theory that the so-called next generation armor package have two generations. The generation 1 of the next generation armor package, or NGAP for short, was first implemented in the older variants, the M1A1SA and the M1A2 Sep v2. Not all tanks, but most of them. However, the M1A2 Sep v3 have the second generation of the NGAP armor. What is the difference, you ask? Well, probably materials, or definitely materials, but not necessarily only materials used to build the armor and its internal structure. As we can see on this photo, notice how much thicker physically is the armor on the Sep v3. You can notice that the gun is elevated more or less at the same angle. Notice on the M1A2 SEPv3 how much closer to the bolts on the gun-mounted mask are the front armor packages. They are thicker, significantly. I also have information that perhaps it's still not confirmed 100%, but perhaps also the front hull armor was physically thickened. It's not confirmed. I only heard so. We will still need to wait for better photographs. However, this photograph shows the front hull armor preparation for the replacement of the front armor packages. So we can assume that the armor is indeed improved here, just like the weight simulators present. No more can be told looking at that photo, but you get the idea. The external armor plates are cut off, the special armor module inside is replaced, and new armor module is placed inside. Then the steel plates are again placed on their position and welded again to the rest of the hull. The first M1A2 SEPv3s from the low-rate initial production are already in US Army service, used for field testing. Here's one of such tanks. These tanks can be recognized mostly because they are still painted in the Desert Tan camouflage. Again, the tank from the field test by the US Army. Notice one thing. The new massive front towing hooks. Similar improved towing hooks are in the hull rear. They're added because of the vehicle weight increase due to the armor. The M1A2 SEPv3 weighted around 63.5 to 65 metric tons. The M1A2 SEPv3 weighs around 71 metric tons. So it's pretty significant weight increase, and if we consider that the electronics become lighter, more compact, the majority of that weight increase comes from the armor, and this is just completely impressive. The new production of the M1A2 SEPv3 tanks shows us that the tanks are in the woodland camouflage. So this means that the US Army is definitely reorientating themselves for more defensive stance in Europe and in the Pacific. Here's another photo. As we can see, all vehicles are painted in olive green and then painted further in the woodland camouflage. However, some parts are still in the desert tan. Why? Mostly because they are reused from spare stocks when these parts were painted in the desert tan in the factory, and some of these parts can still be produced in desert tan before the production fully switches to the olive green. And again, a good photo of the tanks at the production lines in Joint Systems Manufacturing Center in Lima, Ohio. Okay, and here is the tank during the factory trials on the factory proving ground. Again, notice one detail. Do you see a mounting points on the turret side? What are they for? Well, the answer is very simple. They are either used to mount mounting frames for the explosive reactive armor or active protection system trophy HV. Here we can see the attachment points on the turret sides and the whole side skirts. But this tank is particularly interesting not because of these mounting points. It's interesting because it's used for testing of the new Camouflage Paint. The Camouflage Paint is known as Talon or ground vehicle coating system. What is special about this camouflage paint? Well, of course, it's obvious that it is also a new pattern, 4-tone woodland, but also the paint have other characteristics. It's a multi-spectral camouflage pattern, or camouflage paint, if you will. Why? Because it's not only reducing the possibility to notice vehicle by using your naked eye, but it also reducing the thermal signature of the vehicle. So thermal sights or thermal seekers have more difficult time to acquire the target. Probably also the paint is reducing the radar signature of the tank. It's like radar absorbent on the stealth planes. Similar paint, exactly the same paint and the same pattern is tested on the M2 Bradley infantry fighting vehicle. The M1A2 SEPv4, as it was mentioned, will also have the laser warning receivers and a new smoke grenade launchers. Here is the M1A2 SEPv2 used to test the laser warning receivers. We can see there are 4, 2 on the front sides of the turret and 2 on the rear sides of the turret. And also new smoke grenade launchers, the Rheinmetall Rosie. They are smaller caliber than the previous M250 and M257 grenade launchers, but they have more grenades and they are modular design. There is a video on YouTube made by Rheinmetall from the test of this system. So if one wants to seek it and watch it, feel free to do it. Here we can see what are the improvements of the CITV and the GPS. The improved Commander's independent thermal viewer, as it was mentioned, will have 3rd generation FLIR, laser rangefinder, laser pointer and color camera. Improved gunner's primary sight, 3rd generation FLIR, improved laser rangefinder, color camera. Of course, advanced multipurpose ammunition. We can see a model here and a new meteorological sensor for improved firing accuracy. Again, we can see it here. Now we can see also the 2nd generation narrow field of view and 3rd generation ultra narrow field of view. As we can see, in both cases, both the CITV and the gunner sight, the quality of image is vastly improved. It's very similar to improvements made for the AH-64 and AH-1Z helicopters. Here we have the interior of the M1A2 SEPv2. It's a familiar sight. This is one of the General Dynamics Land Systems technology demonstrators for the turret improvements. So perhaps the M1A2 SEPv4 will look like this, but of course it's a thing to change. Notice how more compact electronics become. You can see the improved gunner primary sight. It does not have any optical channels. The day channel is obviously only a camera, and there is no gunner primary sight extension for the TC. There is no need for it. As we can see, both gunner and TC, the tank commander, have unified high definition displays. So both the gunner and the TC can have a view from multiple sensors. The day sight, thermal sight, the commander's CITV, and also the common remotely operated weapon system station, low profile. The cross itself can be, just like the CITV, turned into auto-scan mode of the selected observation sector. So the TC can designate a different observation sector for a CITV, which will scan automatically. The different observation sector for the crows, which will also be scanned automatically by the system. So the TC can observe through his own observation devices two independent observation sectors, and the third sector will be observed by the gunner, also independently. The thing is that the TC on his display can have a view from all these sensors, and probably the gunner as well. So this is the capability that is partially integrated into M1A2 SEPv2, but it will show its full potential in the M1A2 SEPv3 V4. I don't know if there is any other tank with the same capabilities when it comes to the observation devices. Now, the active protection systems. Besides the soft kill system, the laser warning receivers integrated with the new smoke launchers, there is also the hard kill active protection system improvement in form of the Trophy HV. It's the Israeli system, mounted primarily on the Merkava Mark IV main battle tanks and the Nammer heavy APC and heavy infantry fighting vehicle variants. The Trophy for the Abrams is not an integrated system, it's a modular system, which means that the Trophy modules can be installed on the tank or deinstalled, for example for transport purposes. There is a possibility that perhaps the Trophy for the Abrams have more interceptor charges in the autoloaders than that on the Israeli vehicles, because the modules are obviously slightly larger. So, is this the end of the active protection evolution? No. There is also so-called MAPS, or Modular Active Protection System initiative. The MAPS itself is not active protection system per se. It's a universal control software and universal computer that controls the APS. And just like in your home PC, various APS sensors and interceptors can be integrated into the MAPS. So for example, we have the MAPS installed on our M1A2 SEPv4 tank, and we can, for example, integrate with it the universal software via plug and play concept, laser warning receivers, smoke dischargers, and for example Trophy HV or any other active protection system. We can combine sensors and effectors or interceptors of various systems into a single system. For example, we can combine Trophy HV with Iron Fist or any other system. Now, about the further upgrades after the M1A2 SEPv4. It is not a very well known fact that there was already an attempt to install a diesel engine in the Abrams. And this attempt was not very fresh. In fact, first attempt was during the Abrams development. Not very well known fact is that both General Motors and Chrysler Abrams prototypes were designed to both use the gas turbine engine and the diesel. The diesel was the AVCR 1360. However, the AVCR engine, well, it was not reliable enough, and further work on it would delay the program. There was another solution considered, the same engine as the Leopard 2 used, but there were several drawbacks. First drawback was that this engine was very large, and it would require a serious redesign of the engine compartment, which would further delay the program. Another problem was that the Leopard 2 power pack is very heavy, 6 tons. Of course, metric tons. This was again a bit of a problem. The gas turbine power pack weighed 50% less, not 6 tons but 3 tons. It was reliable enough, could be further improved during the production run, and it simply worked and fit into existing hull. So this is why the gas turbine was chosen, besides other reasons. It was never seen as the perfect engine, but it was seen as the good enough engine. But the diesel was still considered. In the 2015 AUSA conference, General Dynamics shown modified Abrams hull, this one on the photograph, with the new M1A2 compact V12 diesel engine. The engine worked. It was integrated with the success and tested also with the success. However, US Army needed to choose. Was there more important priorities than this engine upgrade? Yes, the armor, the electronics. The gas turbine was good enough still. And some of the problems with the fuel inefficiency of the gas turbine could be solved with a new APU. So it was decided to leave the engine upgrade into the future. However, US Army also decided to fund a new program for the family of engines. The competition was finally won by the team of the Akatis Power and Cummins with their advanced combat engine design. The ACE engine is a flat, opposed piston, two-stroke diesel. And it will form a family of the engines. The first variant is the 100,000 horsepower 1000 horsepower variant for the IFVs, APC, self-propelled howitzers, that kind of vehicles. However, second variant is in development, 1500 horsepower. It will be designed for the mine battle tanks, armored recovery vehicles, armored vehicle launching bridges, etc. We can see family of engines here. The combat part of the family. So we have 10 liters 750 horsepower, 13 liters 1000 horsepower, 20 liters 1500 horsepower, and tactical 4 liters 300 horsepower, 5 liters 450 horsepower, 8 liters 600 horsepower. The engine of that kind have many advantages. However, note here, two-stroke opposed piston engines need to be properly designed, and it seems that Akatis Power and Cummins finally nailed the problem, and their engine seems to be enough fuel efficient, have enough service life, and to be reliable enough. The first variant, 1000 horsepower engine, will be tested in the Bradley this year, 2020. It have increased power density, as we know, 1000 horsepower. In the same space climb as Bradley 675 horsepower V903 engine. In fact, the ACE engine releases more space in the engine compartment than the previous engine. We can see it here on the image showing the Bradley engine compartment. Notice there is a red line there showing the height of the current power pack compared to the ACE engine power pack. Also, the new engine have improved fuel efficiency, 20 to 25% better than the current Bradley powertrain, despite high power output. Also, the engine have reduced heat rejection to coolant. Same size cooling system as the current Bradley, despite more power again. And it's a scalable and modular design to provide family of combat engines. The current 1000 horsepower variant will be used in the Bradley IFV, Paladin integrated management, so the M109A7 and the new M1299 self-propelled howitzers, and the AMPV, and also in the future next generation combat vehicles that are not the new mine battle tank. Yes, the US Army is working on the new main battle tank that will replace the Abrams in the future? Will it be a completely new clean sheet design, or will it be the evolution of the Abrams tank? These are two different things. New suspension is also tested. It's a hydropneumatic in-arm suspension system, which gives it several advantages over the current torsion bar suspensions. It's lighter, it does not take any space inside the hull, which means more free space for various components inside. It gives a better, softer ride, more wheel travel, and also another advantages. For example, it can adjust the height of the vehicle. So for example, if you want to hide, we can lower the suspension, making the vehicle lower overall. Or in difficult terrain, or if we are afraid that there are mines or IEDs, we can make suspension higher, making more space between the hull belly and the ground. This kind of suspension is considered now for the M1A2 upgrade into the M1A2 Actually, it's accepted as one of the upgrade components for the M1A2 It's tested on the Bradley infantry fighting vehicle. As we can see, a lot of things changed. It now has 5 road wheels per side, not 6. Here is another photo. And as I heard, soon the same suspension system will be tested for the Abrams. Also notice, these Bradley have the weight simulation plates. Okay, and now about the numbers. So, how many M1A2 SEPv3s were ordered? In total, excluding vehicles that are already produced, that are not on this list, nearly 1,000 vehicles are already built and ordered. To be more precise, 955, including vehicles on this list. Some of them are already made, and vehicles that were built prior to fiscal year 2019. The M1A2 SEPv3 and in the future M1A2 SEPv4 will replace the M1A2 SEPv2 and some M1A1SAs in the US Army active brigades. Meanwhile, the Army National Guard will unify its tank fleet with the M1A2 SEPv2. The Army National Guard have 2 brigades of the M1A2 SEPv2. Additional brigades will be rearmed with the tanks that will be taken from the US Army. The M1A1SAs will serve till 2030, and what will happen with them after that? They will be probably stored and perhaps upgraded into M1A2 SEPv3, V4 or beyond. Same will happen with the Marine Corps M1A2SEPv4. As we know, the Marine Corps is disbanding its tank battalions till 2030. This is 10 years. And from what I know at the moment, probably these tanks will be taken by the US Army. What will happen with them is unknown, but the M1A2SEPv4 is pretty much equivalent to the M1A2SA used by the US Army and Army National Guard. So integrating these tanks into the Army arsenal will be easy. And these will be capable machines for upgrades. Okay, so this is enough. I hope that this short briefing was interesting and informative about what the US Army is currently doing with their tank fleet. We can assume that perhaps US Army decided that their new tank will be the evolution of the Abrams. However, the future will tell. I hope this all again was informative. I wish everyone to stay safe, stay healthy, and we'll see each other in the next video. See ya later!